Ray, thank you so much for your presentation. This is a phenomenal new innovation in the cake industry, and I am so glad to be part of this presentation.
Yeah, very key design feature to move forward from what has previously existed, which creates just such an issue. The nice thing in this case is that the four-legged base, that's the structure of the entire CakeOMETer with thermocouples and everything, is placed in pretty much the geometric center of the pan, and therefore, as the baking begins, nothing moves. So you're assured of reliably repeatable data. That's very key for all thermal profiling, and now that's available to cake baking bakeries as well. Lynn, would you like to take that one?
Yes, and we suggested to the Wheat Marketing Center to use the TAXT2 from Texture Tech, and we recorded firmness on day 1 and firmness on day 3, and found significant difference between day 1 and day three. As usual, that's how you record stilling rates. So obviously day 1 started with a higher hardness than day 3 for the control versus the variable. The control was basically what was recommended as a baking temperature, and the variable was what we felt was a better baking profile. And actually, the data actually shows that baking the cake at a lower temperature and a longer time actually gave it more chance to expand. And we saw that through, Ray, what was it? We saw that through a later arrival. So arrival apparently is really important in cake profiling. So we saw that in the later arrival, and we also saw that in specific volume. So how airy the cake is, for some of you who aren't very familiar with the term, specific volume is the volume divided by the weight, okay? The control had a lower specific volume, like really a tad bit lower, okay? Because the arrival was earlier on, so it cooked more. So when your arrival is earlier on, it's cooking more. If your arrival is later, it's cooking less, right? So what the cake thermal profile showed us is a lower temperature, had a later arrival, therefore it gave it more time to expand, give it more time to have a higher volume. And I personally believe anything that starts with a higher volume is softer, okay? Anything that, so it goes back to your emulsification system, your processing system. If you can put as much bubbles as you possibly can in the system, and you end up with more bubbles, that actual cake is going to stale less. I mean, the stilling rate is going to be not as much, okay? So this data actually shows that the higher the specific volume, the softer the cake, the less it stales. So I hope that answers your question.
Yes, that can be a flexible amount. Interestingly, sure. What we're so the idea there is that, for instance, if you wanted to use the cakeometer with your mold for multiple pans, yes, that's certainly doable. You could actually dedicate with multiple cakeometer bases. Actually have with a 6-channel device, you could actually be profiling six different pans. We would recommend, however, at least uh, uh, 2, 4, 6, three pairs of two, such that you keep that oven ambient sensor metric, as well as the just above the bottom measurement with the ambient probe and one base probe in three cake pans. The idea is that this also helps you balance your ovens, so to speak, such that irrespective of pan location, that the pan that you do choose to profile is in actuality very representable of the entire oven. When it's not, you do want data across or from lower to upper pans to do the profiling. So there is some flexibility there. But what comes with the kit are two bases and an air probe.
So I've always been asked a question on where the proposition should be, how many probes should we use, should it be, done this way or that way. My suggestion to you, since I don't know much about your cake making or cake baking process, is the most important thing to look for is reproducibility. So when you use probes, when you run your test, make sure that your tests are reproducible. Once, if you're in this different position, you're going to get different results. It's not going to make sense to you. So if you're going to use use one probe in all tests. If you're going to use two probes, use two probes in all tests. But either way, I think you're going to be a better judge of your process if you're able to produce reproducible data. That's just my suggestion. Oh my goodness, it'll be so excellent. This is the most innovation I've seen in cakes, and therefore you can use this to bring it over to gluten-free baking, because gluten-free baking, especially the ones that don't focus on yeast to make bread, it focuses on a chemical leavening system, and this is what this probe is specialized for. This probe is specialized for a chemical leavening system in terms of understanding the gelation and the arrival times, right? So definitely use it for gluten-free baking. We don't have enough research and data in that field yet. So this is telling you how innovative and disruptive this technology is. We don't have enough data in that field yet to recommend to you what to look for. You are at the edge of your particular field and understanding this and putting in the principles that work for you. So you need to use this to run lots of tests on your end to understand how it will benefit you in your gluten-free baking. So when we started on the control, we felt that 390 was a really high temperature. you know, I feel like maybe that was a recommendation for home ovens, you know, where you really need to go up just to get to 375. But we were working with an industrial oven, so that's why we felt that was really high. And it goes to say, it goes with any ovens that you work with. When you commercialize your product from one line to the other, you're not going to work with the same oven in different plants. You're going to be working with plants that have direct fired oven, plants that are indirect fired oven. And, you know, where do you start? You know, you start by understanding what kind of oven you work with and whether the temperature is too high for the oven, and then understand if you can optimize the process. And that's what CakeOMETER does. It optimizes your process. If you were to bake 390 on one line, you cannot bake 390 on the other line. It's just, you know, I have hardly seen any processes duplicated in different ovens. I've commercialized a lot of lines, and those ovens just don't work similarly. That's why we went down on the temperature with a longer baking time, because it showed us that it gave the better longer time to expand and provide a higher volume. So this data totally amazed me, and I was all over it. So that's why we went down on the temperature.
One thing I can say is, whereas there's a dearth of information even on extracting that out to, or protracting that out to actual bake out times, even for dough based goods. So this is breaking new ground, and
Yeah.
between
I
the
was just going to say that we're breaking new ground. We don't know. And I'll be honest with you, if you ask me, I don't know. I've never seen this kind of data before. What ECD is doing is completely new. No cake baking research has really indicated an arrival temperature, or, you know, to me, arrival temperature is the point where the entire cake turns from a batter into a porous sponge, right? No data on that yet. So this is how this is how we're operating right here. You know, we're doing something new and we don't have data on it. I would love to collaborate with anyone out there who wants to learn more, but right now I'm afraid to say you're on your own in understanding arrivals and how to manipulate arrivals to your desired texture and your desired shelf life. This is going to be something that you have to do on your own for now, unfortunately.
For now, as you see here on the table, if you still have the ability to look at that, is that range between 69 and 70 and 71 there. So it is quite well, actually, even the low 80s there. So the time and temperatures had a lot of effect on that, obviously. And of course can be easily tracked by the aid of the MolMap software, which is tracking that in real time here. As soon as you downloaded the profile data, so that will help you see what you're currently producing, and then do those post bake stalling tests to help determine.
I think it has a lot to do with understanding the mechanism behind staling. And staling in cakes is really caused by the starches forming bonds with each other. Um, the emulsifiers and the fats and all the other high sugar ingredients, prevents that from happening, right? So stilling in cakes has got a lot to do with the mechanism of how these ingredients cross-link with each other. What I think is going on here is the evaporation of water is getting the molecules away from the sugar, from the emulsifiers. Therefore, they are going to link tighter to each other. But they're still, preventing the starch molecules to align and hold hands, right? So if you compare a cake and a bread, a cake is always going to stale less because of this than a bread, okay? But I feel like moisture being driven out of this system is going to be the main cause of increased staling in the system.
Yes. In other words, you're measuring a combination of ambient air and inside the oven and in the batter, or those same probes could be inserted into a dough piece. We do have other products for that. For instance, something called a breadometer. But yeah, certainly. The same software applies. The same techniques applies. With the aim of repeatable consistency. So you can have a high yield production, bringing more profitability to the business. And the only difference with CakeOMETER is the ability to now fixture a batter product that is stable. You can rely on it being stable. It's not moving, and it's repeatable. But yeah, would equally apply to dough goods. Depending on the product, gelatinization and arrival are programmable. So similarly to the fact that the arrival is typically 200 Fahrenheit for dough products, and that's actually programmable here. As is the gelatinization value. So this metric that occurs naturally as a dough or batter product goes through the process of being baked, if that needs to be a different threshold temperature. Based on the science of setting, making these values. These particular numbers that are in the software are so popular that most people go with what's there. First of all, it is programmable, and is a good milestone. Obviously, a very valuable milestone to adjust. And so to tune an S curve in this case is to change when you have when you have control over multiple zones in an oven. Then that is where the work starts to increase a temperature such as we did in the cake test here to get arrival where we wanted it, with keeping an eye on gelatinization as well. there anything you could add to that, Lynn, as far as determining gelatinization?
I think that you have the information set up to record gelatinization and arrival already, Ray. I don't think that needs to change, and it still shows on the software. So just pick those numbers out and study it. What I would really try to understand is, are there other temperature points that are important to your system? I want people to know that this is a US based cake. It's an entirely different system from the cakes that are used for the rest of the world. And we use chlorinated flour. We have high ratio, so the gelatinization is going to be different from a system, say, that is like a sponge cake with lower sugar, so those are the kinds of things that we don't know yet because we haven't studied. Right now, the parameters showed here are basically from the bread field, what we have studied in the bread field, what we know in the bread field. So like I said, this is totally new data, totally new research. So you might have to really figure that one out for yourself. What is your arrivals? Are your arrivals before 200 degrees Fahrenheit? Are they at 180? Are they at 190? Because we really don't have the answer. We're tagging it at 200 degrees Fahrenheit right now. So those are the things that you have to research for yourself. And I believe the software is flexible enough for you to really change those numbers as well. Say if you want to tag your gelatinization temperature at, say, 155, keep tagging 155. You don't need to follow ECD's recommendation of gelatinization. Okay. It's whatever that works for you. And I believe once you put a process in place, you should be able to see the differences, and you should be able to learn what particular part of this graph contributes to the quality attributes that you're looking for.
Yes, great question. Because there's all different kinds of pan size. There's loaf pans. For
For like a pound cake.
for pound cakes, for instance, and say you had, of course, this is a standard 6-inch. I mean 8-inch. We can go down to 7-inch, but say even we have a pan something like this, two or three of the legs still fit into it.
Okay, so what I'm hearing is, Ray, depending on the pan size, you should try to fit the CakeOMETER in it. And it looks to me like it can do most loaf pans and round pans. But it might be challenging into a muffin pan. You know what I mean?
Oh, yes, yeah. There's a certain size that is just too small, period.
Yeah, so that might be a challenging thing. So what I would recommend is, we did this a lot in Wendy's. We actually take a pan and we cut it up, and send that pan through in the middle of the oven. So this is something that you can do if it doesn't fit into your muffin pan, is take a smaller size of the muffin pan and, try to jury rig it to a point where it fits right underneath the CakeOMETER and send it through. For now, that's, I think that's such an excellent question. I think you have pretty much found, the limitation of this particular probe. But I said for now, if you're interested in this probe, then that's what you have to do. You might have to cut up your cake pan.
If that's among multiple varieties of cakes that you are baking, what you could do if there's not physically room for the approximate 6-inch breadth of the base legs, is to simply release the knurled knob and pull out one of the probes and to place directly into the cake, and as Lin puts it, jury rig something there. If it's like only three or 3 inches across or something. Yeah.
That's true. I mean, as a researcher, as a commercialization specialist out on the floor, we are always tasked by getting the best quality out of each line. And I have a lot of empathy for those of you who are tasked with that, because sometimes you're given what you're given. You know, you can't work with the best conditions, and sometimes you just have to come up with innovative ways to make certain things fit. So I hope by bringing on this CakeOMETER, I was really interested in showing, you know, our cake bakers, you know, this new innovation. I hope it opens up doors to you and helping you understand your final quality. And I would love to hear any feedback from any of you. If you do use this, you know, give me a shout out on LinkedIn, social media, whatever, you know, show us pictures of it, hashtag CakeOMETER, you know, and I'd love to see it working in the field. Okay. Now, we do have to wrap it up because we are past our time limit. Ray, thanks so much for coming and presenting your new innovation. And also, whoever's behind the camera, thank you so much for helping out.
Thanks to you.
We appreciate the opportunity. Thank you all very much for attending.
Thank you. Bye-bye.